So today we're going to talk about Kiota, our modern OpenAPI client code generation written in .NET. In fact, as of yesterday, using .NET 8. My name is Daryl Miller, and with me is Vincent Biret, who's going to show you the code. We are both from the Microsoft Graph Developer Experience team. Our team build API client SDKs in order to call the Microsoft Graph, where all of your data from M365 lives, your emails, your calendars, your SharePoint files. And we produce those SDKs in 6 different languages and 2 different command line experiences. So why did we go and build Kiota? So there's about 2 million active applications calling Microsoft Graph, but only about 500,000 of them are actually using the SDK. And so the question we had to ask, well, why is it? Why are people not using these libraries that we build in order to make it easier for them to call the SDK? And just this is not actually unusual. We've talked to a number of other large API providers, and they commonly see this fairly low adoption rate of using packaged SDKs to call APIs. So we went talking to customers and got all kinds of feedback from them. Classic one, "Oh, I don't need an SDK. I know how to make HTTP calls." And when we dug into that question, a lot of the times, what they were really saying is, I don't want to learn another SDK because HTTP is a consistent way of doing things. It's a consistent mechanism for making network requests, and people have learned how to do it. And yet, when API providers build SDKs, they have a set of opinions of how to abstract that away. And so you end up learning things all over again every time you move to a new SDK. People will tell us, yeah, I don't want the dependencies. And you can imagine that being the case if you have an application that calls multiple APIs, you start pulling in multiple SDKs, they're pulling in JSON serializers and client libraries that have different versions, and you end up sort of getting these versioning conflicts that can happen. People will say, "Oh, I didn't know there was an SDK. I went and read the docs. It showed me how to do an HTTP request, and I just assumed that was the way to do it." Discovery is a challenge for SDKs. People will tell us, I need high performance, low latency, low footprint. And when you're working on an API the size of Microsoft Graph with 22,000 endpoints, it's very true that the package size is pretty big. Not the kind of thing that you would want to ship on a mobile client or in a spa application where bytes matter. People will tell us, I don't know why I need it. I know how to make a simple basic HTTP call. I know how to process the response and JSON. But a lot of people aren't familiar with a lot of the edge cases around HTTP, are not familiar with some of the weird rules around percent encoding of Unicode characters in URLs, or specific functions of certain headers, or specific status codes that might come back from some kind of intermediary. And their app works fine until something out of the ordinary happens, and then it breaks in production. We also get the feedback, I've used the SDK, but it's really poor quality. I can write something better myself. And what happens is, unfortunately, it's really expensive to go build SDKs for an API provider in many different languages. And so people turn to automatic generators, and there's poor open API descriptions out there, and there's poor quality SDK generators. And we're trying to solve that by building better quality SDK generators, or API client code generators, should I say. I mean, another option is we could just turn around and say, well, let's just stop shipping client SDKs. Obviously, those 25% of customers who do use SDKs are going to be fairly disappointed. And what we have observed from our customers is those customers that do take the time to generate the SDK, to use the SDKs, end up building better quality applications because they take into account many of these edge cases. And so, what are the options that we have here? Well, this notion of a self-serve API client is something we've explored. And this is not a new concept. When you go to call a GraphQL API, you don't go and download a GraphQL SDK for a particular API. You just go and use your favorite GraphQL tooling. If you want to call a gRPC endpoint, you can go use Proto-C and generate a client. As long as you have the proto schema, you can generate the client in order to call the API. And Yes, SOAP. One of the things people did actually like about it was being able to go into Visual Studio, go to service reference, point to a WSDL file, and there you have a client. I mean, the challenge there was a few days later, something would change and it would break, but that's a different problem. There are so many more HTTP APIs out there, and the adoption of OpenAPI as a description language gives us a really big opportunity to build the same kind of self-serve experience for HTTP APIs. And so this is why Kiota is different. This isn't a tool for API providers to go build SDKs. They absolutely can, and we are doing it. But this is really targeted at the consumer of APIs. If you're building an app and you want to consume a bunch of APIs, we are going to give you an experience. There's a VS Code extension where you can go find open API descriptions. You can select just the endpoints that you care about, and we will generate just the code that your application needs in order to be able to call that API. And it doesn't matter which API you're calling, the code's going to feel the way, it's going to use the same conventions. And we were working really hard to have complete open API support. One of the reasons for poor quality of existing SDK generators is they don't do a good job of supporting all of the different things that you can do in an open API description. We're also really opinionated about the surface area of the client that we generate. We do not try and generate the most beautiful, most optimized for the scenario experience. What we try and do is take those HTTP concepts that you already know about and bring them into your programming language and deal with those exceptions and edge cases around HTTP that a lot of people don't know about. And the great thing is, we already needed to go build this for Microsoft Graph. We were funded to go do this, but we are really serious about this being truly an open source project and not just a source open project. We have a number of contributors. We're working with Red Hat, we're working with GitHub, and there's a bunch of independent contributors who have contributed features and capabilities to our library, and we intend to keep it going that way as a true open source project. So what does this app kind of look like when you go and use our client code generator? Well, as I say, you start with the Open API description and you use our VS Code extension to go find that Open API description and select the endpoints that you want. And then from those endpoints, you generate that client code. Now, we don't recommend that you go and take that client code and use it all throughout your application. A lot like what Steve was just saying in the previous session about API client code lives in infrastructure. You should create that interface layer, that service adapter that brings an app specific interface so that you can mock it, so that you can do configuration around observability over the top of our generated code. That generated code calls into a set of abstractions, which out of the box leverages our built-in core libraries for native calling of HTTP libraries, serialization, authentication. But you can completely replace those. If you want to use different libraries, if you want to add additional serialization for additional media types, you absolutely can do that. And so this is all fully replaceable, and it supports easily calling many APIs from within your application in a simple, clean way. But I've talked too much. Let's let Vincent show you how it's actually done with the code.
Thank you, Darrell. Hi, everyone. So today we're going to build an application using Kiota. My program manager, Seb, who didn't join us today, is very frustrated because it takes a while for us to review the pull request, get the code merged, and get features delivered and shipped and so on. And he has asked me to build an application that's going to take the pull requests from GitHub and create to-do tasks, which is a personal organization application for each pull request. This way, people will get reminders, they can prioritize them, and so on and so forth. So here you already know, love, and use GitHub today. We have a couple of pull requests in this repository here. And our goal again is to make sure that for each pull request, we're going to create tasks in to-do here. So let's go to VS Code. And again, new project. I don't know GitHub very well. I will, or it's a REST API. So I'll try to see if I can find a REST API. As you can see, I have Kiota installed as a VS Code extension here. Kiota comes in two flavors: the VS Code extension that is integrated with VS Code that I'm going to be showing in a couple of seconds. That's in public preview today. And it also comes as a CLI that's in general availability today. And it's cross-platform. You can use it on a number of different OSs and platforms and whatnot. So because I have Kiota installed in VS Code, the first thing I can do here is search for an API description. And I'm going to be searching for GitHub because, again, I want to get the pull requests from GitHub. So Kiota is going to go over a couple of indices here and try to find API descriptions for GitHub. And I happen to know that the right one to use is this one here, which I'm going to be selecting. And what it's going to do, it's going to grab the description here and load us a representation of the API and the different path segments on the API and the different operations that are available in the API and whatnot. By default, you get everything selected, but again, I want a very small and lean client. One advantage of Kiota is not only you can generate your own client for any API out there that has an open API description, but you also get to select the operations you're interested in and the paths that you're interested in to generate a client that is very specific to what you want to do in your application. Again, it's a large API description, so let's try to filter it. And let's try to find a pull request here. So when I filter the description here, you will see that there are a couple of ways to get pull request. One of them looks like you need the commit ID first, and it's not going to be very practical to get each commit and then get the pull request. So we'll ignore that for now. But then under repos, the organization name, the repo name, I have a pools segment here, and it looks like what I might be interested in. And if I want to know more about this specific operation here, I can click here to open GitHub's API documentation right away and see that. And actually, let's do that for a second. And you can see that it takes you right away to the pools endpoint and its documentation that's provided by GitHub. So now I know that this is most likely to be the endpoint that I'm interested in, and I'm going to be generating a new client for that. So when you have a Qt client, you have one root entry point, which is the client class, and this is where the Fluent API surface will start from. And because we want to make sure that the code that is being generated by Qt fits very well with your project, that can be organized and structured a number of different ways, Qt will ask a couple of questions before it can generate the code. The first thing being, what's the main class name you want to give? So I'm going to call this GitHub client. The next thing is in which namespace or package name or equivalent in your ecosystem do you want me to place the generated code? So it fits very well with your project structure and you don't have to reorganize your project and your application around Qt clients. So I'm going to call it GitHub to do demo, which is the name of my project today. And let's put it under GitHub here. And the third question it's asking me is, which folder do you want me to put things into? Again, so it fits very well with your project organization. So here I'm going to put it in the GitHub folder. And lastly, it's going to ask me about which language I want to generate the code in. Qt supports multiple languages from C#, Go, Java, and many others. And you will see that each language falls into one of three buckets. Either it's a stable language, which means that it's ready for production use and you can generate clients, add them to your application, build solutions, and start going to production with that. It also means that as long with newer version of Qt, we won't make changes to the code generation that will break your application or that will break your code. It will keep working. And if we have to do some kind of change like that, we will change the major version of Qt and document the aspect and tell you, hey, warning, now this has changed and be careful with that. Preview is almost stable, but there might be still a couple of rough edges on some scenarios, and we might still make changes that might break your code as you update Qt to the latest version and regenerate your clients. And experimental is we barely started the work to implement that language. It's most likely broken for most scenarios. You're welcome to try it, but be very careful with it. It's not production ready. So today, of course, we're at the .NET Conf, so we will generate a C# client today. So let's go with that. So what it's going to do is it's going to, again, grab the description that we already have, use the different configuration that I put here, and generate a client with that within my repository. We can see now that I have a new folder here in my console application that is called GitHub here with all the different things. One thing which is really interesting to note with Kiota is every time you generate a client, you get this Kiota log file here that, let me close that, keeps all the settings that you've used during the generation of a client. So this way, Kiota also offers update commands and other commands. If you want to refresh your client because the API description has changed, or refresh your client because you have a newer Kiota version, you're able to do just that, and it will remember the different parameters and the different paths you've selected when you initially generated the client here. So we have our client to query GitHub's API. Also, because we don't have a lot of time today, I went ahead and generated another client for Microsoft Graph that has been generated using the CLI. Again, you get the same exact engine under the covers. One is just an integration in VS Code. The other is the CLI. They both will produce the same results. But those are the different capabilities you can have here. And if you want to look at the command that I used to generate the .NET client here, it looks something like that. It's Kiota generate to generate a new client, the language that we had, the namespace name that we talked about earlier, the output directory that we talked about earlier, the client name, the description URI, and the different include or exclude patterns. And we should also support global patterns here as well. And this will generate the Microsoft Graph client in that case. Again, I've already run that earlier in the interest of time. So now that we have both our clients, let's try to explore the different clients and the different APIs that are available now. So the first thing I will do to get it out of the way is I will include all the usings. So this way we have references to everything we need, and we don't need to come back to that later on. And now I will create a GitHub client from my client that I generated earlier. So a couple of things here. First, again, I said Kiota clients provide a Fluent API surface, and I know what is this called because I gave it the name it has, so I know where to start. It requires a parameter here, but again, we don't know Kiota. We're just exploring today. We'll get back to that later. We just want to look at the API surface and understand what it provides and what it does, right? So now that I have a client for my GitHub API, I can do GitHub client dot, and what do we have here? Well, we have something called repos, which looks promising because we know that repository that pull requests are under repositories, right? And then if I dot my way through, I don't have anything really interesting except this indexer. If you don't know about indexers, it's okay. It's just a way in .NET to map into specific items of a collection using a key here. So I'm going to be providing the organization name or my GitHub handle here. Let's dot our way through again, another indexer. It looks like it's asking me for the repository specifically, the repository name. And then let's dot our way through again. And now we have something called pulls. And that looks very interesting because, again, we're trying to get pull requests here. Now let's dot our way through again. It starts to be really easy to do that, right? And we can see that we have a get async method, which will allow me to get the different pull requests, right? That was easy. In a couple of minutes, I was able to search for an API description, explore it through the API Explorer view, generate a client, and write pseudocode that looks like something my application will be able to use, right? Let's try to do the same thing for Microsoft Graph. Let's call it Graph Client here. New Microsoft Graph Client. Again, I gave it this name so I know how it's named. We'll replace the null values later on. And now that we have a client here, we'll do the same thing. I work on Microsoft Graph, so I happen to know that /me or .me in that case maps to the current user who is connected, who is identified to the application. It's a shorthand. It is as if I did /users/user ID. Okay, and it will allow me to access the current user's data. And then under that, we have a to-do segment. Well, we know that we want to create tasks in to-do, so that looks pretty obvious here. And then under that, we have something called lists. So if you don't know to-do, that's fine. The way the tasks are organized in to-do is they belong to task lists. So you can have different categories or different themes of tasks, one for groceries, for example, one for reviewing pull request, one for something else. But every task is within a list, right? And so here we know that because it needs to belong to a list, well, we need to get a list ID first. And then after that, we can get to do tasks. Again, in production, I would not doing it like that. I would maybe create my specific list for pull requests, check the name, check the different things. But here we're doing demo code, so it's fine to do those kinds of things for the interest of time. And now let's get the first list here of the collection. Again, never do that in production. Check that you have the right data, check that you have the right things and whatnot. And now that we have the first list, well, let's try to create a task within that list. So again, I'll use my graph client here. E.lists, sorry, the to-do first. Oh, to-do lists. Let's see what we have after that. Well, we also have an indexer like we used earlier, so let's do that and use it and provide it with the list ID that we collected earlier. And then from that, we have the tasks. Finally, we can access the tasks. And after that, we have a couple of different methods, but one which is really interesting to us when we want to create tasks is to use the post async method. So again, thanks to the Fluent API, I can discover that easily. And in addition to the different Fluent API surface that the clients you're generating provide, Kiota also provides you with all the models that are described by the API. And so it will handle for you automatically serialization, deserialization, and other complex aspects like that. So I can do right away, create it to the task and set the title to something and whatnot, and this will create it to the task. So again, in a couple of minutes, we've been able to discover two different APIs, get their descriptions, explore the different paths and API segments that they provide, generate clients, and write pseudocode to kind of build the logic of our application here. Now, all that's left is to feed the pull request into the to-do tasks and to create a to-do task for each pull request. I'm not going to make you suffer for me type slowly, so I'm going to use a snippet here. Oops, sorry. Snippet instead. And so here, let me add a missing await here. And so what this is doing effectively, it's iterating over each pull request using the Fluent API to create a new task here. And for the new task, we're setting the pull request title, we're setting a due date, we're setting the importance to high because Seb is really impatient. He really wants us to review the tasks and that pull request. And lastly, we are adding a link resource. So we will have a link to the pull request right within to do. So it's easier to find it and to open it. Now, before we can go ahead with this application, I don't know if you remember, but when we created the clients, we passed null here because we just wanted to explore the API surface and the different clients. Well, one thing that's going to be left is to make sure that we have the authentication set up. So I'm going to do that for graph really quickly. Here, I'm going to be using the device authentication flow for both clients, but again, you can be using any number of authentication providers and any number of authentication flows here. And I'm going to be doing the same here for GitHub. And now everything is set up. I have my different clients, we have authentication and everything set up. So I can just run the code here. And the first thing it's going to ask me when it talks to GitHub is to go sign in to GitHub, actually using the device code flow. I'm going to move that here. There we go, building, building, building. And here, so it's telling me, hey, to sign in, you need to go here. I have way too many windows open. And authorize. There, we're signed into GitHub. And now that my application can talk to GitHub, we'll do the exact same thing for Microsoft Graph in that case. Again, sign in. There we go, continue. And here we'll see, not here, here we'll see that my application just created two tasks. And if we look at Microsoft To Do here and refresh the page, we should see our two new tasks, sorry, not my day, I want all the tasks here. I always get caught by that. We see that we have our 2 tasks that have been created, and we have a due date and the link and the title and the importance and whatnot. Again, in a couple of minutes, we've been able to explore 2 APIs, generate clients for them, write the code, and integrate 2 APIs together thanks to Kiota and generating our clients. With that, I'm going to hand it back to Daryl so we can close the session and we can take a couple of questions. Thank you.
Thank you, Vincent. It always makes me nervous when you live code that. It's just when it comes to authoring to 2 API services, there's always things that can go wrong. This is our short link for to go get Kiota. It's a GitHub repo. Please give us feedback. Tell us what you like. Tell us what you don't like. This is what is driving our progress. And with that, thank you very much.
Wow, that was pretty cool. And honestly, you guys made it harder on me because you answered questions as you were developing because you were tag teaming. When one person was doing the presentation, Daryl was answering questions there. This is really great. And honestly, it's very cool because, like, from my perspective, as an API developer, right? I'm constantly just writing API and creating an either using something like Swashbuckle in ASP.NET Core or anything like that, and having it auto generating my endpoints, my specification, right? So, but then you're like, oh, well, how is XYZ person going to consume this?
Mm-hmm.
Yep.
Right. So selfishly for me, I'm like, this is great. I can just, since you have a CLI tool, I can use Kiota to just generate the library for me, generate the NuGet package.
Yep.
Right.
That someone can consume and everything else. Now it makes it harder on me, harder air quotes, because now I have to literally be meticulous about documenting my specifications, which we should all do anyway.
Yeah, and we're .NET developers. We want PHP developers and Python developers.
Right.
But don't ask me to go and produce an SDK for Python or PHP.
Right.
But I can point consumers to this tool and say, here's a bunch of tooling. You just point it at our API, and you can go use it to consume the API that I just built for you.
And the nice thing about it, though, is like as you, for example, like you mentioned about being .NET developers or PHP developers, it's like you could start in one way or another, right? Say you start with PHP and you're using Kiota to generate it. Oh, now I have people who are interested who are .NET developers. Mm-hmm. Now let me output that for them, right? And it's the same tool, which is amazing. What was the development, sort of what was the synthesis that drove, the Graph team to get here? Because then obviously Graph is just a big API landscape, right? Mm-hmm. So how did you guys get there?
I think you answered your own question. Graph is a big API. And so we needed something fast, something that scales to our needs. And we thought that developing it in the open would benefit the broader community and the industry. Right. And so this is why we did it this way.
Yeah, no, I think it's great because obviously you have the Graph API, and when that looked like, if you step back, you also have Azure, right, which is more of like the layer underneath of it. So I can see, all right, well, Kiota, all the things, right? So that way it's the same generator for the SDKs that Azure has available, and hopefully synthesize it a little bit better.
Well, Azure have taken a slightly different approach and have slightly different issues because they have many APIs that are all smaller, and so we had scaling problems. We tried to use auto-rest initially, which is what the Azure team used, but throw the whole Microsoft 50 megabyte OpenAPI file at auto-rest, and it wasn't very happy. So we had to build tooling that was able to handle something that was that size. And they also have a lot of teams that work on really crafting the experience specifically to the service that we're building. We're a small DevX team with a very large API. we couldn't do that, right? So we went for the consistency route and asked people to, layer a service adapter over the top of our HTTP specific opinionated API surface.
Right. No, I think, and I love that answer because that way it provides myself as someone who could be in those two camps, right? Mm-hmm. I like large API surface or small, very slivered services, and allows me to do both, right? And streamline that output, right?
Yeah.
Exactly.
Great. Awesome. Well, thank you so much, gentlemen, for taking the time to present here at .NET Conf. Always, I was blown away.